So let's look at those ionic solids. Ionic compounds are going to have crystalline structures that are related to those unit cells that we looked at earlier. But a complicating factor here is that we are going to have two different kinds of ions, a cation and an anion, instead of having just one kind of atom. Here, the coordination number is going to represent the number of close cation-anion interactions. And in general, the more similar the size of cation and anion, the higher the coordination number. These crystal structures have to balance not only coordination number, but charge neutrality and different ion sizes. So there's a huge variety of different types of crystal structures in ionic compounds. We're just going to take a little peek at it. So if we look at ionic solids where the ions are similar in size, an example is cesium chloride. So we have the green chloride ions, and the cesium ion is similar in size. And this is going to take on a simple cubic unit cell. What we want to look at here is just one of the ions, not both of them. Because if we look at both of them, we might say, well, that's a body-centered, right? Because there's one smack dab in the middle. But in looking at the unit cells, we have to just look at one kind of ion. So here, if we're just looking at the chloride ions, then we see that this is making a simple cubic unit cell, right? Just ions at the corners. So we've got the ions at the corners, and then we've got one cesium atom in the middle. So the coordination number here is 8. This one is touching all the guys in the corners. What is in this unit cell? Well, obviously there's one cesium ion, and there's an eighth of a chloride ion at each corner. So there is also a total of one chloride ion. And this is the kind of question you might see on the ACS exam. It'll give you a picture, a drawing, and ask you how many ions of each are in this unit cell. Well, looking at the charges here, we got plus and minus, or the mole ratio here, one of each. It has to be the same number of each, right? So if we just think about the green ones here, that's a simple cubic cell. Just tell by looking at the shape of it, that's going to have one chloride ion in it. If there's one chloride ion, it has to have one cesium ion. Several different other ionic solids are going to have the same structure. Example is calcium sulfide. So let's look at sodium chloride. Well, if ion size was the only thing we had to worry about, we could fit a lot of these little tiny sodium ions around all these chloride ions. But then it wouldn't be neutral, and nature really doesn't like that. So we have to have an equal number of chloride ions and sodium ions. So again, we can identify this type of unit cell by ignoring the purple ones and just looking at the green ones. See, okay, well, what's going on with the green ones here? So there's the basic cube, and then there's another green one here. This is on the face. That one is on the face over there. This one is on the face on the top, the face on the left, the face on the bottom, and the face on the back. This is a face-centered cubic unit cell. And the sodium ions are in between those. So how many chloride ions are in a face-centered cubic unit cell? All the guys at the corners make up one, and then we have half and half and half and half and half and half, total of 4, right? So there's 4 chloride ions, and then there must be a total of 4 sodium ions. It's really hard to look at that and try to count those up. This is called a rock salt structure. So if the sizes are even different, even more different, something like zinc sulfide, here again, let's just look at the sulfide ions to see what kind of a structure this is. So here's one face, and look, there's a sulfide ion in the face. So this is also face-centered. But now, instead of the zinc ions being along these edges like the sodium was, these are kind of stuck in the middle. These are called tetrahedral holes because if you look at how this guy, it's stuck between 4 different sulfide ions, and so that's a hole in this tetrahedron. And when you have 1-to-2 ratios or 2-to-1 ratios, now you have to accommodate twice as many of one ion compared to the other. So here, calcium fluoride, we've got 2 fluorides for every calcium. So again, just choose to look at one of the kinds of ions to see what kind of a structure this is. So there's one side, and here we have a calcium in the face, right? So again, this is face-centered cubic. And now we have more fluorides in here. Turns out there's 8 tetrahedral holes in there. And so here, all of those are going to be occupied. So how do you identify the number of cations and anions? Well, here, what we're looking at as forming the cubic unit cell, the face-centered cubic unit cell, is the calcium ions. Face-centered means 4. Oh, face 4. There we go. So the face-centered is 4 ions of calcium. There must be twice as many fluoride ions as calcium ions. So then that must be 8.